Hi, everybody. Thank you for joining us for another Armor lecture. Starting off with a land acknowledgement, I want to acknowledge that the Field Museum was built within the traditional homelands of the Council of the Three Fires, the Potawatomi, Odawa, and Ojibwe nations, as well as the Ho-Chunk, Winnebago, Meskwaki, Sauk, Illini Confederacy, Menominee, Kickapoo, Iowas, Otway, Missouri, and Miami nations. Chicago was and continues to be an important place of trade, worship, and interaction for many diverse peoples. And we remember that this land was and remains Native land. Today, I'm pleased to introduce the Field Museum. Oh, yes. Is that better? Okay. All right. Thank you. Today, I'm pleased to introduce the Field Museum's very own Dr. Laure Dussubieux. Laure is a senior research scientist in the Ghani Integrative Research Center and lab manager for the museum's elemental analysis facility. She's a chemist who studies the composition of ancient materials made from glass, metal, and stone. Before coming to the Field Museum in 2004, Laure earned her PhD in chemistry from the University of Orléans in France and served as a postdoctoral fellow at the Smithsonian's Museum Conservation Institute in Maryland. While there, Laure developed applications for the use of LAICPMS and portable XRF to studies of cultural materials. As manager of the museum's elemental analysis facility, Laure maintains and manages the use of various analytical instruments, including LAICPMS, portable XRF, and Raman spectroscopy, which I can never say. Laure has published widely on her studies, but has most extensively researched and published on the circulation of glass beads around the Indian Ocean. Aside from her incredible research, I am grateful to Laure for her coordination of internships and informal lectures with her anthropology colleagues. This year, the EAF celebrated its 20th anniversary, and I look forward to hearing more about the facility and its various research applications through Laure's presentation today. So please welcome Dr. Laure Dussubieux.
I would like to thank Stacy for the introduction, and I would like to thank you all for being here with me to celebrate the 20-year anniversary of the Elemental Analysis Facility. I hope everybody is hearing me well. So we celebrated this anniversary in different ways. And today, what I would like to highlight is the research we have been doing for 20 years, and more especially the research we have been doing about glass bead circulation around the Indian Ocean. So first, maybe I should say what exactly is the Elemental Analysis Facility for some of you that might not be very familiar with the lab. This was founded 20 years ago with NSF Major Research Instrument Grant to Gary Feynman, Patrick Ryan Williams, Meenakshi Wadhwa in geology, and Phil Janney also in geology, the two first person being colleague in anthropology. The central piece of the Elemental Analysis Facility was and is still what we call laser ablation inductively coupled plasma mass spectrometry, or LAICPMS. And it's an analytical technique that is used to determine the composition of inorganic materials, ceramics, metals, and glass, which will be the topic of this lecture. It can determine a very wide range of elements. We analyze up to 58 elements, and they can be major, minor, or trace elements, so they can have very variable concentrations. What is really important is that it's minimally destructive. It leaves no visible damage at the surface of the object that we analyze. And this is possible by using a laser ablation system that is sampling our artifact. And we use a laser with a diameter of 60 to 80 micrometers, so it's less than the diameter of one of your hairs. And it's very convenient when studying beads because some of them are very small. They can be 1 millimeter in diameter. So this way we can study them, and they are still here with us. They are not destroyed. So I would like to give you a little background about using LAIC-PMS in the framework of glass research. So we use LAIC-PMS to determine the composition of glass. And first, we can consider the major and minor elements. They are important to reconstruct the recipes that were used in the past, because different ingredients will lead to different compositions. So by measuring this composition, we can access the kind of recipes ancient glass makers were using. And those glass recipes, they were region-specific because glassmakers would develop a recipe based on ingredients that were available around them. But also sometimes some ingredients would run out, or they would lose access for one reason or the other. So there would be some change in time for those glass recipes. So knowing the composition of a glass can be useful to have an idea of where the glass comes from, or what is the time period the glass was made. And by extension, you have information about circulation of object and also interaction between different regions. So when you look at trace elements, you access a new level of information. So what is in the first box? It's what I just said about minor and major elements, give you access to recipes that usually are region-specific. So I put region 1 and region 2. But within those regions, you have different workshops. They will still use the same recipes, but they might be using different ingredient sources. So that will be the same ingredient, but they won't be located at the same place. You will see later that for glass, we use sand. And sand is a very bulky material that is pretty cheap by itself, but if you were to transport it far away, it would cost quite more than the price of the material. So usually workshop would set up close to a sand source. And those sand sources will have distinct trace elements. Trace element being those elements in very small concentration. Usually we put a limit of 0.1%. And so if we have same recipes, if we have same composition, major and minor element, okay, we are within the same region, but if we see different trace element patterns, that might mean that the glass comes from different workshop or sub-region between within the region that we have been defining for a specific recipe. So that's why we are really looking at all the different elements, major, minor, and trace. It just brings us different information. So we are going to focus our attention now on the Indian Ocean. And what I'm going to talk about today, it's glass beads that were made in what I will call South Asia. And it's not really the true definition of South Asia that I mean by that. I will encompass in this word India and Sri Lanka. In those two regions, there was a specific type of glass bead that was manufactured. And that's what we are going to talk about. We are going to talk about those beads in particular because they are the most abundant around the Indian Ocean. Other beads were traded, but in smaller proportions. So I thought that focusing on the most abundant one was making sense. So first, I want to try to explain you why they were so abundant, because I think there is a good explanation for that. So here you have a group of beads that come from a site in Sri Lanka. And I choose this picture because you can see different bead technology represented. By example, you have a wound bead. That's a red bead at the bottom that was formed by winding a small lump of molten glass around a metal rod. And you can see other wound beads. The dark blue one that is on the right above the molded one is also a wound bead. So some people, some bead maker would also mold beads. That they would take a mold, they would pour glass into it, make sure to insert something. It depends on that can be a metal rod or something else to keep a hole open for the bead. And also people were using lapidary techniques. So they were using glass as like a stone. They would grind, drill, polish, like they would do it for stone beads. And that's the example, the transparent blue bead. So those beads have to be, they are made individually. And there is a fourth type of bead on this slide that is a drawn bead that can be made in a large number at once. And I will explain you that. And here you have two types of drawn beads. On the left of your screen, you have segmented beads that usually are manufactured around the Mediterranean area or the Middle East, and that start during the Roman time, and you can find that in the medieval time and later. On the two picture on the right are drawn beads manufactured in South Asia with a different technique. They would just break when a tube of glass was cold, solid. They will break them in tiny pieces without any segmentation or anything. So this technique of segmented bead is kind of efficient because you are making several beads at once. So it requires to blow air in a mass of glass to make a hole, and then it's drawn into a tube. And while the glass is still soft, the tube has to be pinched at regular interval. Usually there is a rod into the tube to keep it open. And once the pinched tube is cold and solid, the beads are cut, snapped. And so it's a good way to make drawn beads, but craftsmen in South Asia found a more efficient way to do that. Actually, there is still a group of craft people in the village of Papanai Dupet in Andhra Pradesh that is still making beads in a traditional way that we think was developed maybe 2,000 years ago. Different articles have been written about the technique used by those craft people. There is also a movie that was made by a French team of researchers that you can find on YouTube if you're interested. And my colleague Alok Kanungo, that is an Indian glass specialist, also wrote recently a book to document the way those craft people were making beads. And that's a very efficient way to make beads. Maybe I said that, but I will say it again because it's pretty impressive. Here on the left of your screen, you have drawings that represent the type of furnace they are using. And you have a picture of the same furnace on the right. I know it's not very easy to understand the correlation between the drawing and the picture. But what is important to know is that, so you have this, I don't know if you know, I cannot point, it's okay. So you have on the side of the furnace a platform that is sticking out. You can see that clearly on the drawing. And that's where a chunk of raw glass are going to be put so as they melt. And they are going to melt and be shaped into a conical lump of glass. On the largest end of the cone, a tube is going to be affixed. This tube is called the ladder. You can see it on this drawing on the left. And you can also see it. You see the picture represent a white cone of glass with on the left the ladder that is inserted in it. And this ladder being a tube, the worker are going to insert a metal rod that they will push into the glass so as it pierces the cone. And they will remove this rod. And they are going to maintain the lump of glass, the cone of glass, pierced into the oven so as it stays soft. And they are going to use a certain aperture for that. And on the opposite side of the oven or the furnace, there is another aperture that will be used by a second worker to grab the end of the cone that is pierced hollow, and it will pull a tube out of the furnace. The tube, I would say, will be 2-3 meters long, and it will be broken from the cone, and the worker will go again inside the furnace, grab the end of the cone again, and pull another tube. And it will repeat the operation until there is no more glass at the end of the ladder, the tool that is holding the ladder into the furnace. And once those tube will be solid, they will be broken in glass bead size pieces. This picture is really terrible, and I apologize for that. So I tried to draw what was going on over it. Maybe that will help you, maybe not. We will see. So here, what I drew in white is a blade that is in the ground. I mean, it's not moving. It's put here on the ground in front of the worker, and this person is going to put tubes. What is in red? I try to make tubes of glass. On the edge of this blade, and with this other end that is holding another blade, is going to hit those tubes on the spot where they are resting on the bottom blade, and that will separate some pieces of those tubes that will fall. Let me see. Yeah, not sure you can see them on the left, and this way. Quite a lot of beads can be produced, but they have sharp edges. So there is another step that consists of coating those beads with powdered cow dung. That's to avoid that they will stick together and that the whole collapse, and because they will be heated again and stirred until the edges are turned round. And I like this picture of this lady then, because then the beads are clean and sieved, so they are sorted by size, and then they are strung, and that's how they are sold then. But I like this lady with this really huge quantity of beads in front of her. It might be, I don't know, thousands of beads. And this can be manufactured very quickly. So craft people in South Asia had a very efficient way to produce large quantity of drawn beads, but they also had a very innovative way to produce glass. Usually in other regions, like in the Middle East, in the Mediterranean area, glass makers would use several ingredients to obtain glass. Because for glass, what is needed is a source of silica. Usually it's a sand. That can be a sand from the beach. That can be other type of sand, as long as it has 50, 60%, 70% of silica or more. It's fine. And then we need what we call a flux. A flux is an alkali or alkali earth-based ingredient that we add to the silica-based ingredient so as to lower the melting point of the silica, because silica has a melting point that is 1700 degrees C, and that's a temperature quite difficult to reach for traditional glass makers. Plant ashes, or you might have heard about natron, which is a soda-based mineral, were used as a flux. But those ingredients were not pure, so they would bring, by example, for the sand silica, but they can also have iron or alumina or calcium or other constituent. And those constituents can also be helpful. By example, calcium is a stabilizer for glass and prevent the glass from dissolving in water. So by mixing those two ingredients, usually traditional ancient glassmakers were able to get everything they needed to get a good glass. Of course, they could add then colorant and opacifier, but this is not essential to make glass. So craft people in South Asia, glass makers, they found a way to make glass with just one ingredient with everything you need in your glass: silica, alkali, and stabilizer like calcium. So there are places in India and also in Sri Lanka where the soil is saturated with salt, sodium-based salt. And when the soil is waterlogged, so there is a time where the soil is waterlogged, and when there is evaporation next, the salt is going to migrate towards the surface of the soil and create a sodium-rich efflorescence that you can see on the right of the screen. And when the glassmaker collects this efflorescence that is also containing sand from the soil, they have a raw material that contain everything that you need to make glass. And also those soils, they are very actually problematic. It's not something people will want because you cannot cultivate on them. So I imagine that that was a pretty cheap raw material, and that was a good way to valorize some pretty cheap land. So, this glass made in South Asia also contains a lot of alumina, and we call it mineral soda high alumina glass. And that's something you are going to hear me saying a lot in the rest of this presentation. So this glass is made from a quite easy and cheap ingredient. And it's used to make beads that can be produced by the thousand. And those beads, if you saw one of the first slides I showed, they are small monochrome beads. So they can be combined in different types of jewelry. They can be used on clothing. So I would say they are very versatile and can appeal to a lot of different people just because you can do a lot of different things with them. So I think in South Asia, they got these beads that were good candidates to be really easy to trade around the Indian Ocean because they could provide a large quantity of them. Saying that they were cheap is being maybe a victim of our modern value, but I'm pretty sure that they were more complex and expensive products, so they were quite likely accessible to more people than other beads. So before I arrived here, I got a PhD, and it was about glass from South and Southeast Asia. And in the 600 glass bead I analyzed with LAIC PMS in Orléans, a little more than 1/3 of the beads had mineral soda alumina composition that seemed to indicate that they were coming from South Asia. But at that time, I would obtain this big cloud of point. Here you have the concentration of sodium in the glass that would vary a lot, from 10 to 20%, and the concentration of alumina that would also vary a lot, between 6 and 14%. But there were not much more we could say about that. In this data set, you have glass from Sri Lanka, India, and different countries in Southeast Asia. Looking at the trace element, we could see something was going on. Here you have barium and uranium, and there was also a lot of variation, but it seems that we could see some grouping with points that had beads that had higher uranium concentration. But that wasn't a lot of beads, so it was really hard to interpret that. So then I came to the Film Museum, and when I arrived, the curator for African archaeology was Dr. Chap Kusimba, and he had excavated quite extensively in Kenya, more especially at the site of Mtwapa. And there he found those small monochrome glass beads. The dating of the site was very wide, 10th to 18th century C. Around the same period, Chap Kusimba had a guest. It was a Bass scholar that was Dr. or Professor Vishwas Gogte from Deccan College in India. And he excavated the site of Chaul. Chaul is on the west coast of India in Maharashtra. And there also glass beads, those monochrome, small drawn glass beads were found. And looking at their composition, they had a typical composition of South Asian glass, but they were almost all of them with higher uranium concentration. So it seems that something was going on here, that was really a meaningful glass group. And we used, on the first graph, it was just 2 trace elements. We used more elements to see how we can separate better the different types of glass that we could kind of see with 2 elements. We use magnesium, calcium, zirconium, strontium, cesium, barium, and uranium. For the blue glass, it's only glass from South India and Sri Lanka. The glass bead from Chaul are green, and then you have the Mtwapa beads from Kenya on top of them. So what you can see is that you had 2 subgroups of glass in South India, Sri Lanka, compared to Maharashtra. And that was suggesting that there were 2 different glass-making regions in India. And that the glass from Mtwapa was quite likely coming from Maharashtra, maybe through Chaul, but there were also other ports that could have been options. So through time, we accumulated more data from different places. The problem is for archaeological material, it's not like going to the supermarket and say, I want this, this, and that. You kind of need to wait that people make interesting discoveries that will help your research. And my colleague Alok Kanungo excavated a site in northern India, in Uttar Pradesh, called Kopia. That was very interesting from a glass perspective because there were glass furnaces and evidence of bead making and possibly evidence of glass making. The analysis of glass sample from this site revealed the same mineral soda alumina glass that we expect in India, but different trace element patterns that was showing another glass producing region distinct from South India and Maharashtra. Then more data came in orange, slightly different from the glass from Kopia, was glass from Putakaruang. It's in Indonesia. The glass wasn't made there, of course, but because he had a very typical South Asian composition. So that was likely glass made in India that was moved to Indonesia through some trade exchange. It was a later glass, and it was vessel, which is a little unusual because in India there is very small glass vessels that were produced at early periods. It's become more common at later period. So that is indicating yet another possible region of manufacture. And finally, on the east coast of Africa, at the site of Jwani Primary School in Tanzania, another glass with a typical Indian or South Asian composition was displaying different trace element pattern. So going this way, we could, not always with data taken from objects found in India, realize that in India and Sri Lanka, there were some sub-regions that produced glass. And as you can see, there is also some chronology attached to it. Some glass were made at earlier periods than others. So more recently came along my colleague, Dr. Mudit Trivedi. He was working on his PhD dissertation at the University of Chicago when he was excavating the site of Indore in Rajasthan. It's a late site, 14th century, 19th century AD. And there he found more subgroups of this mineral soda alumina glass. It's not very surprising because it seems that at some point in time, there was just a multiplication of the glass workshop in different regions. So we had 5 glass subtype, and when it came with the glass from Indore, we went up to 11. Here on this graph, that has to be 3D to really see anything. You have 10 of the, you have 9 of the 12 of the 11 glass. So here is just a little recap of the different subgroup we discovered through time. As you can see, their chronology is not always the same, whether you find them in Africa or Southeast Asia. The chronology also is very fuzzy because the problem with beads is that they are not always very well dated. So that is a little problematic sometimes to place them in time. So what I wanted to show you is what we are doing with all those data. And I thought that the study of the drawn glass beads of quiche that we have in our collection was a good example. I'm pretty sure most of you are familiar with the site of quiche, but in case, I just will go through different information about this site that is in Iraq. It's not that far from Baghdad, a little south of it, and it's 12 kilometers away from Babylon. And in the past, the Euphrates was going through the site, but then the river moved, and now it's not the case anymore. It's an important site because it's one of the earliest cities in the world, I'm missing L. And it was occupied over a very long period from the Ubaid to the Abbasid period. And the Field Museum with Oxford led several excavations there from 1923 to 1933. And the material that was found was divided in 3, one part staying in Iraq, one part going to Oxford, and one part going to the Field Museum. And among the material that went to the Field Museum, there were approximately 400 glass beads, I'm sorry. And if I say approximately, it's because for some of those beads, it's a little difficult to determine what kind of material they are made of. Sometimes there is ambiguity with faience, by example. And 122 of them were those small monochrome drawn beads. So we analyzed 23 of those drawn beads, selecting some kind of representative sample of what we could find in terms of color and size also, because some are smaller than others. And also, it's important to keep in mind that the context of the glass beads from Kish was pretty uncertain. Some had absolutely no context, and some were said as post-Sasanian. And that's it. That's a little vague. It's 8th century and after, or later. So when we look at the same kind of element that we have been using for the other data, we had to separate different subgroups. We found that the glass beads of Kish would separate in 4 groups. Most of the bead would fit the mineral soda alumina glass 6. We would have 3 beads in the group 2, 2 beads in the group 1, and a few beads in the group 11. So, so we had an heterogeneous sample. Something that was discovered quite recently, and I thought I would put it out there, even if I won't go into many explanations how this graph was built. But looking at the mineral soda alumina glass 1, we recently were able to separate it in 2 additional subgroups, one corresponding to a place of production in Sri Lanka, one corresponding to a place of production in India. And using isotope data and trace element data, so we were able to determine that the Sri Lanka glass had lower vanadium and chromium compared to the East-South India glass. And there is an area of overlap. That's why you have these 2 lines with uncertain between them. It's where those 2 groups are overlapping. But the mineral soda alumina glass 1 from Kish seems to be made with a glass that was manufactured in Eastern South India. So, okay, we know they are from South India. The dating is more difficult because this glass has been produced for more than a millennium. The only thing that was a little indicator of maybe the dating of these beads is that we find similar beads in abundance along the Red Sea. So it's not really the same region, but it's not that far away. And yeah, they are very abundant in the middle of the mid-1st century CE. So it doesn't seem too illogical to think that those beads could have been part of the same kind of exchange network. So maybe those beads are also dating from the same mid-1st century CE period than those other beads that we found a little west in the Red Sea. For the type 2 and 6, very interestingly, they are always present in the same context, although elsewhere they belong to 2 different periods. Usually the type 6 is earlier, 9th to 13th century CE, and the type 2 is 14th century, 17th century. So the fact that they were together there are several explanations to that. Beads, it's easier to keep them over a long period and to recycle them into new jewelry or new ornament. This way, sometimes you have older beads with younger beads. They might also have been deposited at a period that would be at the interface of the 2 periods those 2 glass types belong to. But yeah, it's difficult to say for certain. It's not sure where the glass type 6 is made from, made from. And for the type 2, we know it was circulating through Chaul, but in Maharashtra, although we are not really sure where the glass was made. And we have the mineral soda alumina glass type 11. We know it's from India, but we don't know where in India. It has been discovered recently also that really need more investigation. It was found in the same context that the mineral soda alumina glass 1. So That's also something a little difficult to explain when we assume that the glass 11 is usually later, 14th century and after. So globally, what we can say is that it's not totally impossible that those beads are later period beads from the 13th to 14th century CE, because even if we say that most of the occupation of Kish stopped at the 7th century AD, actually there were some Icanite ceramic at Kish that were found that are from this later period that correspond to a time when the Icanite stretched across this area and from Pakistan to Turkey. And so it seems that that could have actually facilitated the circulation of beads from India to Kish. So it seems that there is a lot of area where we could get more detail about those glass beads, but with this analysis, we have way more information that we had when we started, because initially we had no idea that those beads came from India, and now we know that approximately 30% of the glass beads from Kish are from there. It's quite likely also that it's older material compared to the bulk of the material from Kish. There is this little idea about earlier beads, but at this point, there is really not a lot we can say about it more. And we can see that the beads come from different regions of India. And it's quite likely that they travel through the Persian Gulf, because then they could have come along the Euphrates straight to Kish. So that's the example I wanted to show you. Here are all the places where we had glass beads analyzed with an Indian origin. It seems a lot on this screen, but we need to understand that the Indian Ocean is huge, and at the end of the day, we don't have that many information. The trade pattern of those beads over the Indian Ocean is still extremely sketchy. So what is important to understand is that it's a work in progress. And in the future, we need more data from India, because a lot of the data we have are from outside India in terms of glass type and chronology. Because it seems that when my colleague studies a glass of indoor in India, suddenly he opened the Pandora box. There was so much more information that he found that we had before. We also need to identify ancient glassmaking workshop in India, so as we can match the glass found there with the subtypes that were identified, to try to find where exactly those subtypes were made. And here also, that's the same comment that I did before. We cannot really shop for that. It's really a matter of luck, I assume. People being interested in finding that kind of site and being able to identify them and whatnot. And it would be important to focus on well-dated material from India and from all over the Indian Ocean, because as you could see, our chronology is very sketchy at the moment. I think things are improving, more especially with all our publication. People start thinking that beads are important, because in the past, to be honest, I don't think they were paying much attention. But now they are sieving with finer mesh to make sure they are recovering them, while before they would use a 5mm mesh, and most of those beads they would just go through. And it would be nice also to motivate interest from other teams and labs, more especially in those countries where we found those beads, and in India, by example, where they have students that are really good and they have LAIC PMS. They just need to find the energy to put all that together to have this research progress. And I would like to thank NSF for the funding they provided for instrumentation, and also for yeah, for programs that allow us to bring students working on that kind of topic here to teach them how to use a machine, interpret their data, and etc. I will also thank the Negodi Foundation because they help us with the funding of the laser we are using right now. And these are all the collaborators that contributed one way or the other to this research. I'm sure I forgot people, and I really apologize for that. But yes, that's definitely a collective effort. And I would like to see if you have questions.
Very interesting talk. Thank you. I'm curious, you described in the production of the drawn glass beads that they used a metal blade top and bottom to cut through the tubes. I'm curious what kind of metal that was. I mean, glass is hard to cut.
That's a really good question. I would say some iron-based, like steel or that's a really good question. I have never really paid attention to this detail.
Hi, Laura. Really enjoyed the talk. To what extent is cullet and it being used in the early production of glass? Do you know? And
I didn't hear the word you say.
cullet?
Oh, okay. So what you mean is pieces of glass that they would
trash
use.
glass that you put
Eh,
into the glass to make more
So
glass.
that's a good question. Honestly, for India, I have no idea. But yes, they would use that because it would facilitate the start of the melting of the glass, the same way actually that you use a flux. But in India, we are kind of a little. There is not a lot of evidence of anything. Kopia, the site I mentioned, is one of the first sites that were excavated. That was a glass workshop. So we really are in the dark for most of the process of making glass, really.
Thanks.
Hi, Laura. That was a great talk. Thank you.
Thanks.
I wanted to ask about the social aspects of the bead production, not only production, but like also the use. If you could just slightly, if you have done any of this research or anyone else has looked, because even today the glass bangles are one of the most important things to have at a time when the couple marries, and they get also transmitted through generations, and glass beads are part of the society. So if you could just illuminate the importance. I think it's a long, many periods that you address, but nevertheless, thank you.
Yeah, so I have to remind everyone that I'm just a chemist. So I'm very limited in that kind of interpretation, but I would be really happy to point you at some publication. So what it's really interesting for glass in India is that they were using it more especially in ancient time around the turn of the Common Era, only to make beads and ornaments. They wouldn't use it to make bowls or any container. The only container we find are imported, either Roman or from other places. But so that's something that is making glass very special in this area, is that it was almost exclusively made for beads and bangles and sometimes ear ornament. Then about the social aspect, yeah, I don't really want to say too much because that's really not something I'm studying, but I would be happy to look for publication that I could recommend for you.
Any other questions?
Thank you, Laura. Can you talk about the other glass, the 70% at Kish that was not from India? Do you have any data on where it's coming from?
So there were other glass that was also from India, but that was a different type of glass. But that was a very small proportion. And then there was a lot of glass made in the Middle East. They would make glass from rather pure sand and sodium-rich plant ashes. But very interestingly, there is not a lot of data for glass beads because what they were making very well was glass vessel, at the contrary of India. And most of the focus from glass researchers have been on those glass vessels because they can be really intricate, really nicely done. And so they really attract a lot of attention. Glass beads, compared to that, looks a little like secondary. But there were a lot of, most of the glass was from just the surrounding region.
Hi, Laura. Sorry, I came late, so if you discussed some of this. Do you know, so when the beads were excavated or found, were they mainly in interred burials? Were they in settlements? Do you know kind of where they were, maybe how that chemical dispersion happened between bead types or locations?
Yeah, so yeah, that's a good question. In Africa, I know that in some places they were just in midden. How do you say that? In midden, in where they would throw away stuff. There has been a few places where they would be in burials, but I don't think it was very common. Especially because I don't want to say anything wrong, but I don't think it was really common to put beads in burials. They are in habitation also. By example, in India, one of the biggest glass bead collection is from Pattanam, which was just a port. So that was a trading place, and I guess that's why there were so many beads, because they might have been in transit there. There are a few places that's production place of beads, like I worked on the material of Giribawa in Sri Lanka, where glass was quite likely made, and also beads, and you can find beads everywhere on the ground there. It was just because it was made. So it varies. It can be in burials, it can be in house context, can be in a trade, like a port. So it really depends.
Okay, I have a question. So I know that certain areas of Kish had a lot of issues with the water table changing and flooding. And I imagine being so tiny, is that part of the reason that the context of the beads is not well known? Or is it for those other reasons, like excavation wise, that you were talking about, that people weren't looking for them?
So no, I think they didn't record anything, but that's true. That beads have this tendency of traveling up and down very easily, because they're like, for some of them, like a very big grain of sand, and they're round, and it's not rare that they trickle down. It's rarer that they trickle up, but yeah, that's often a concern when you see something that look a little weird in your chronology, more especially if it's isolated. That might be because of some movement through the different layers that were post-deposition. So.
Any other questions? All right, thank you so much.
Well,
Laura.
thanks a lot.